understand that rest and motion, they are the relative terms. If a person is sitting in a chair in his office or home, he is stationary, he is not moving. He says that I am stationary because his distance with respect to the walls and the other furniture items is fixed. It is not changing with time. But what about if the same person is being observed from moon by a person who is on moon? This person who is on moon, he observes that his earth is moving. If the earth is moving, obviously that this person is also moving along with the earth. So that person will say that this person has some velocity. But this person says that is my velocity, my speed is equal to 0, I am stationary. So rest and motion, they are the relative terms. Generally, earth is our reference frame. Now we shall be understanding the reference frames. Reference frames, they are of two types. One is inertial reference frames. They are also known as non-accelerating reference frames. That is inertial reference frame or non-accelerating reference frames. The other kind of reference frames, they are non-inertial or accelerating reference frames. Non word is, out of the two, non is associated only with one. Either you say non-inertial or accelerating, or inertial or non-accelerating. There is nothing like non-inertial, non-accelerating reference frame, that is not possible. When we say reference frame, it is primarily, you can say whether this observer who is making the equations of Newton's laws of motion, we have done T minus mg is equal to ma, all those equations we have done. So obviously there is some observer who is seeing that event happening and he is writing those equations. If this observer is accelerating, then it means the reference frame is an accelerating reference frame. If this observer is stationary with respect to earth or moving with a constant velocity with respect to earth, then we say this is a non-accelerating reference frames. Generally, when we say that is a body is moving or stationary, at the back of our mind, our reference frame is earth. So now let's understand that is what do we mean actually by reference frame. Let's understand it by a simple example where there is a lift, there is a 10 kg block and this lift is going with 2 meters per second square in the upward direction. We are asked to find the value of this tension. As usual, we draw a circle, we draw a free body, we say that is tension is this way, 100 Newton is this way, and this elevator is moving in the vertical direction upward with the acceleration of 2 meters per second square. Now, someone has to make the equations. Obviously, we write the equation, that is fine, but where is our observer? Our observer is here. This is person on the ground. So, our person on the ground, right now, he is the observer who is observing the whole event taking place. He is stationary with respect to earth, so he makes an inertial or non-accelerating reference frame. Theoretically, even earth is not an inertial reference frame because this is rotating. The rotating frames, they are also accelerating frames. But for all practical purposes, we take that as this acceleration is very small, so we take it as an inertial frame. As we have done earlier through force diagram or free body diagram, we draw a circle, we look at the forces which are associated with this body. So 100 Newton is in this direction, T is in this direction. We have drawn a circle, we focus on this, we draw the forces, and then we say that is T minus mg is equal to ma. This acceleration is observed by a person who is on the ground. He is writing these equations. That is, this acceleration is observed 2 meters per second square from the ground. It is not from inside this elevator, that is from the ground. So that's why he is writing the equation T minus mg is equal to mass into acceleration, and he gets T as 120 Newton. This person who is attached to the earth, that is who is not moving with respect to earth, who is not accelerating with respect to earth, so he himself make an inertial reference frame or non-accelerating reference frame. He is not accelerating. This reference frame is not accelerating. With respect to him, with respect to this reference frame, this body is also going with 2 meters per second square. So this equation, what is written is, it is with respect to earth or with respect to this observer is one and the same thing. There is no relative acceleration also between the two. So you can say that is this equation is with respect to, that is with this inertial reference frame or this inertial reference frame or observer, that is one and the same thing. When we apply resultant force is equal to mass into acceleration, it is essential that is our observer, our reference frame should be non-accelerating. If the observer is accelerating, then we have to slightly make a change in the equation F is equal to ma, and then over there we have to add the pseudo forces or fictitious forces so that we are in a position to apply F is equal to ma. Let's understand that is what is meant by this. So over here we have made an equation with respect to this person, inertial reference frame. Suppose the person is over here in the lift. He says, I am going to apply F is equal to ma, that is resultant force is equal to mass into acceleration. So this person sees that this body is stationary with respect to this person. He sees that his acceleration of this is equal to 0. If he sees that acceleration of this is equal to 0, he will say that is 100 is equal to t. So he will say t is equal to 100 Newton. Whereas the t is 120 Newton. If this person fixes a spring balance over here to take the reading will not be 100 Newton, the reading will be 120 Newton. So it means that there is something wrong over here, that is when we directly apply F is equal to ma with respect to this accelerating frame. This lift is accelerating in the upward direction. So this observer is also accelerating up. When the observer is accelerating up, this is an accelerating reference frame. So he cannot directly use F is equal to ma. If this accelerating observer wishes to apply the equation F is equal to ma, then in addition to all the real forces, whatsoever the real forces they are there, in addition to all the real forces, he will add one more force on the observed object, which is called a pseudo force or a fictitious force. So now what is the magnitude and direction of this fictitious force? Magnitude of this fictitious force, imaginary force, is mass of the observed body into, that is multiplied by the acceleration of the observer or reference frame. So magnitude is mass of body and acceleration of reference frame. It is product of these two. And what is the direction? Direction is opposite to the direction of acceleration of frame. So now what does it mean? It means that is when this is moving, lift is moving at 2 meters per second square, the reference frame which is attached to the lift or a person who is the lift, that is one and the same thing, he is also accelerating 2 meters per second square upwards. So what he will do is, in addition to all these real forces T and 100 Newton, he will add one more force. What is the direction of that force? That is opposite to the direction of acceleration of this person. He is accelerating this way. So pseudo force onto this, he is observing this block, so he will add a force onto this block in this direction. Please understand, it is not opposite to the direction of motion, it is opposite to the direction of acceleration. It may happen that his lift is retarding this way, so then it will be accelerating in this direction. So whatsoever the direction of acceleration, the pseudo force direction will be opposite to the direction of acceleration of the observer. This is very important. Please do not confuse it, that is in which direction the observer is going, it is in which direction observer is accelerating. If the observer is accelerating in this direction, in the upward direction, onto the block, he will apply a force in the downward direction. If the observer is accelerating in this direction, then onto the block, he will apply the fictitious force in this direction. If the observer is accelerating in this direction, he will apply a pseudo force on the object in the opposite direction. So pseudo force is applied in the direction opposite to the direction of acceleration of the observer or reference frame. So we have got the direction. So the direction of pseudo force is in this direction. Now what is the magnitude of this pseudo force? This pseudo force has a magnitude of mass of the body is 10 into acceleration of this person. Acceleration of this reference frame is, he is going with a lift only, so his acceleration is 2 meters per second square, so this comes out to 20 Newton. So now this person, he has fulfilled all the necessary requirements to apply Newton's laws of motion. Now he can directly apply laws of motion. Now he says that is this block is stationary with respect to me. It means that if this is stationary with respect to me, it means summation of forces in y-axis. So summation of forces, net force along y-axis is equal to 0. It means upward forces, they have to be equal to downward forces. So it means T is equal to 100 plus 20, that is 120 Newton. And this is the answer which matches with the person who is on the ground and writing the equation T minus 100 is equal to 10 into 2. That is T is equal to 120 Newton. These are the equations with respect to a person on the ground, that is with respect to a reference frame, inertial reference frame. This is the accelerating reference frame. From both these things, the answer comes out to 120 Newton and it matches.